All right, let's go through number one. Number one is a sine curve. Notice how our A value is -3, but remember amplitude is always positive. So our amplitude is going to be 3, but our curve is going to be reflected. Okay. The period of a sine curve is calculated by taking 2 pi divided by b. Now our b value is 2, so we're going to take 2 pi divided by b to get a period of pi. Okay. Our starting point is calculated by taking c over b, comma d. Okay. I think we can all agree that our d value is 1. Okay. Now, here, this is our bx minus c. So our c value is a negative pi, and our b value is 2. So when we come over here to our starting point, we have negative pi divided by 2. Okay. Now I'm going to go ahead and draw our frame. Remember, our starting point is where our frame begins. I am going to go up A to 4, down A to -3, and then we will draw our frame. Okay. Sorry, that was not straight and that was better. Okay, here we go. We are going to split our frame in half, and then in 2 quarters. Okay. Now, our frame begins, sorry about that, at negative pi over 2. If you're going to use method 1, then we're going to take the period of pi and we are going to add it to where we start. So if we add pi to negative pi over 2, we get a positive pi over 2. Now we're going to find midpoints. If I add these two together, we get 0, and 0 divided by 2 for our midpoint is 0. If I add these two together to get negative pi over 2 and then divide it by 2 for our midpoint, we're going to get negative pi over 4. And then similarly over here, we're going to get pi over 4. Okay. Now, maybe you like method number 2. Maybe you like to take the period and divide it by 4 and add that 4 times. Okay, so if that's the case, we're going to add pi over 4 times. So if we add pi over 4 to negative pi over 2, we get a negative pi over 4. If we add pi over 4, we'll get 0, add pi over 4, add pi over 4. Okay. Now, we're going to go ahead and draw in a sine curve that has been reflected. So we're going to use our quarter marks and we're going to go down first since our sine curve is reflected. Okay. We do want you to label these points. So here's negative pi over 2, 1. We're going to come down here, and you know what? You've all been wondering this. This should be a -2. I am so sorry about that. This is negative pi over 4, -2. Here we're at 0, 1. Here we're at pi over 4, 4. And here we're at pi over 2, 1. If you caught that -2 before I did, good job. Our domain for any sine or cosine curve is all real numbers. And then since we know that this graph oscillates in the frame, we can go to the bottom of our frame, to the top of our frame for our range. Let's talk about graph number 2. Since our A value is 2, we're going to identify the amplitude to be 2. It does not appear that we have a coefficient other than 1 for our B value, so the period remains at 2 pi. For our starting point, we don't have anything added to the end, so there is no vertical shift. However, we do have a horizontal shift to the right, pi over 3, and the B value is 1, so that does not affect it. So we have a starting point of pi over 3, 0. We will draw our frame up to and down to. Okay. Here is our frame. Okay, so we are starting at pi over 3. The period is 2 pi. So if you're going to do method number 1, we are going to add 2 pi to pi over 3. Now I'm going to think of 2 pi as 6 pi over 3 in order to get my frame to end here at 7 pi over 3. Okay, then I'm going to find the midpoint. So if I add these two together, we would get 8 pi over 3. But when we divide it by 2, we would get 8 pi over 6. Okay. If we add these two together, we have 5 pi over 3 divided by 2 for our midpoint is going to give us 5 pi over 6. And if we add these two together, we get 11 pi over 3 divided by 2 for our midpoint will get us 11 pi over 6. Now, if you like method number 2, then we can take our period, cut it into 4s. So we'd be adding pi over 2 to each of these, okay? So you would start at pi over 3. When you add pi over 2, you would get pi over 6, 5 pi over 6. If you add another pi over 2, you get 4 pi over 3. If you add another pi over 2, you get 11 pi over 6. If you add another pi over 2, you would get 7 pi over 3. Okay. It doesn't matter which method you choose as long as we can get those labeled correctly. Okay. Now we have a cosine curve. A cosine curve starts in the corner of our frame. So I know that this is our starting point. That's where our frame starts. But then we will begin to draw our curve since it's a positive cosine curve in the top corner. So we have pi over 3, 2, 5 pi over 6, 0, 4 pi over 3, -2, 11 pi over 6, 0, and 7 pi over 3, 2. The domain of any sine or cosine curve is all real numbers. And since this oscillates in our frame, and our frame stretches from -2 to +2, that's going to be what our range is. let's talk about graph number 3. Now, graph number 3 is a tangent graph. I'm going to recognize that our A value is 1. However, a tangent graph does not have any amplitude. Okay, we will use A to draw our frame, but it is not considered our amplitude. Remember, we calculate the period of our tangent graph by taking pi divided by b. Now, in this case, our b value is 1/3. So we are going to take pi divided by 1/3. Now, when we do that, dividing is the same thing as multiplying by the reciprocal. So we are going to get 3 pi as our period. Okay, now the starting point, we still take C over B comma D. We can recognize that our D value is 3. So I'm going to go ahead and fill that in now. Now for C over B, remember this is BX minus C. So I see that our C value is a negative pi over 3 and our B value is 1/3. So what's happening is we have negative pi over 3 times the reciprocal. So C over B is going to get us negative pi. Okay. So let's remember that the starting point for a tangent graph is going to be in the middle of our frame. Okay. So we are still going to draw the frame like we would for a sine or cosine graph. Our starting point is just in the middle. Okay. So since our starting point is at negative pi 3, we are going to use the A value to figure out how tall our frame is. So we're going to go up to 4 and down to 2 in order to get this frame. Okay. Now, negative pi is right here. Okay. If you're going to use method 1, then you are going to take the period and cut it in half because we need half to the right and half to the left. So if I take pi and I add 3 pi over 2, we would be getting 1 pi over 2. Okay. Now, if I add these together, to get negative pi over 2 and divide by 2, we would have negative pi over 4. Okay, now let's go the other way. If I subtract half of our period, so if I subtract 3 pi over 2, half of our period to negative pi, we would have negative 5 pi over 2. Okay, and to find our midpoint, if I add these together, we would have negative 7 pi over 2. Cut that in half, we have negative 7 pi over 4. Okay. Now let's talk about method number 2. If instead you wanted to just take the period and cut it into 4s, if you wanted to take the period and cut it into 4s, we would have 3 pi over 4. Okay, so you could take negative pi and add 3 pi over 4 to get to negative pi over 4. We could add 3 pi over 4 to get to pi over 2. Same thing, we could take 3 pi over 4 and subtract it twice to get to these places right here. Now, The tangent graph, a little bit more exciting. We have asymptotes that are on the edge of our frame. So we have asymptotes here at x equals negative 5 pi over 2 and x equals pi over 2. Please make sure you are labeling these as lines. If you write just the numbers, you will not get full credit. Okay, now this is a tangent graph that has a positive a, so we know for sure it's going to go through the starting point, and then we use the edges of our frame and those quarter marks to get the other two coordinates. And we know that these are going to approach the asymptotes. Okay, so negative pi 3 is a coordinate we want to label. Negative pi over 4, 4 is a coordinate we want to label. And negative 7 pi over 4, 2 is a coordinate we want to label. Notice how this in both directions vertically is stretching on forever. So our range is all real numbers. We will not ask you to identify the domain because the domain is broken up by an infinite number of vertical asymptotes. Talk about graph number 4. Since we are talking about a cosecant curve, there is not going to be any amplitude, but we can recognize that A is 1, and that will help us draw our frame. Okay. Since this is the reciprocal of a sine curve, we're going to calculate the period by taking 2 pi divided by b. B, it looks like, is 2. So our period will be pi. Our starting point, we're going to take c divided by b, comma d. Our c divided by b looks like is going to be pi divided by 2. And then we don't have anything added to the end, so we don't have a vertical shift. Okay, so when I draw my frame, we're going to use A to go up and down to draw the vertical spacing of our frame. So we're going to go up 1 and down 1. Okay, we're beginning at pi over 2. So if I add pi, that's the length of the period, we would get 3 pi over 2. If we want to find the midpoint, I can add these together to get 4 pi over 2 divided by 2 for our midpoint. That would get us pi. If I want to find this midpoint, I take pi over 2 plus pi to get 3 pi over 2, cut that in half for our midpoint to get 3 pi over 4. Add these two together to get 5 pi over 2, divided by 2 to get the midpoint, we have 5 pi over 4. Now, if you wanted to use method number 2, we can take our period and cut it into 4s. So we would be adding pi over 4 every time. If I take pi over 2 and add pi over 4, we get 3 pi over 4. If I add another pi over 4, we would get 4 pi over 4, 5 pi over 4, and 6 pi over 4. You decide what works best for you. Now, everything I do in orange is my light color because it's not really there. Okay, cosecant is the reciprocal of sine. So this is what our sine curve would look like. However, we're graphing cosecant. So anytime our curve, our sine curve hits these middle marks, we're going to have an asymptote because the reciprocal would be undefined. Okay, So we have asymptotes at pi over 2, pi, and 3 pi over 2. Okay. Now, these other coordinates are where our u's will be. Okay, so at 5 pi over 4, negative 1, and at 3 pi over 4, positive 1, we have our u's. Okay, and if you want to, you can erase this curve right there so you don't see it. But if you have it drawn in really, really lightly, that is totally fine. Okay. Okay. Now our range, our black curve is what we're looking at. We have a u that goes from negative 1 and below. And we have a u that starts at 1 and gets bigger. So our range is negative infinity to negative 1 and positive 1 to infinity. Let's talk about graph number 5. Once again, since we're looking at a reciprocal curve, we are not going to have an amplitude. Okay. It looks like the coefficient of x is 1, so our period 2 pi divided by b. Let's talk about graph number 5. Since we're talking about a reciprocal curve, we are not going to have an amplitude, but we'll keep in mind that since our a value is 1, that can help us draw our frame. Okay. It looks like our b value is 1, so 2 pi divided by b, our period will remain at 2 pi. Now, keep in mind this is bx minus c. So when we take c over b, we're going to have a negative pi over 2 divided by 1. And then there's nothing out here, so we're not going to have a d value. So our starting point is negative pi over 2, 0. Okay. Now our frame is going to stretch up 1 and down 1 since our a value is 1. Okay. Remember, this is the reciprocal of cosine, so we're going to act like we're drawing a cosine curve for a moment. So our frame begins at negative pi over 2, and our period is pi. So if we add 2 pi, or 4 pi over 2, our frame is going to end at 3 pi over 2. If we add these together, we get 2 pi over 2 divided by 2. Our midpoint is pi over 2. Okay, if we add these two together and divide by 2, this midpoint is at 0. And if we add these two together to get 4 pi over 2 divided by 2 to get our midpoint, that would be at pi. Okay, now maybe you would rather take 2 pi and divide it by 4. Well, that would be pi over 2. Then we could just add pi over 2 4 times. So negative pi over 2 plus pi over 2 plus pi over 2 plus pi over 2 plus pi over 2. That one worked out pretty nicely, didn't it? Okay. Now, secant is the reciprocal of cosine. So I'm going to draw in a positive cosine curve here. Okay. Remember, it's my orange, so it's really light. It's not really there. I'm going to take these coordinates right here, and those are going to become our asymptotes. So we have asymptotes at x equals 0 and x equals pi. These coordinates on the edge of our frame are going to give us our u's. Okay, you are welcome to finish those u's if it bothers you, but technically this is what would be considered one period. So I'm going to label 3 pi over 2, 1, pi over 2, -1, and negative pi over 2, 1. If you wish, you don't have to draw in that cosine curve. So I'm going to erase mine if yours is there. Just make sure it's really light and the u's and asymptotes stand out. Then we're going to identify our range. We have curve below and including -1 and above and including a +1. Let's look at graph number 6. We're looking at a sine curve, so we can identify the amplitude to be the absolute value of A, which is 1/2. It looks like our B value is 1, so we can identify the period to be 2 pi. Our starting point, C over B, since B is 1, we have pi over 2, comma 0. So here's our frame. We're going to go up A and down A for our frame. It's going to help us identify the range of our curve. Okay. We start here at pi over 2. If you use method number 1, we're going to take the period and we're going to add it to get where we stop. So pi over 2 plus 4 pi over 2 will give us 5 pi over 2. Now let's find the midpoint. We add these together to get 6 pi over 2 divided by 2 for the midpoint. We will get 3 pi over 2. If I add these two together, we would get 4 pi divided by 2 divided by 2 to get pi. If I add these, we'll get 8 pi divided by 2 divided by 2 will give us 2 pi. Now, if you instead wanted to take the period and cut it in 4s, that would be pi over 2. So we could take pi over 2 and add pi over 2, add pi over 2, add pi over 2, and add pi over 2. Okay, this is a normal sine curve, so we're going to start at the starting point and go up first to make our sine S. Okay. And we're going to label our 5 important points. The domain for any sine curve is all real numbers. And then to find the range, we know this curve is oscillating between our frame. So our frame stretches vertically from -1/2 to +1/2. Let's look at problem number 7. Number 7 is a cosine curve. It looks like A is 3. That will help us with our amplitude. Our B value looks to be 2. So when we take 2 pi divided by B, pi will be the period. Now, remember this is Bx minus C. So when we look at our starting point, C over B comma D, let's just go ahead and identify that our D value is 2. Now, our C value is 3 pi divided by 4. And we're dividing by 2. So keep in mind that when we divide, it's the same thing as multiplying by the reciprocal. So when we identify C over B, it looks like we're getting 3 pi divided by 8. It feels strange, but that's okay. All right, so if our starting point is 3 pi over 8, comma 2, we're going to draw our frame. Okay, so our frame is going to go up A and down A. Now it's beginning at 3 pi over 8. And we have the period of pi. So method number 1. If you're going to use method number 1, we're going to add pi. So I'm going to think of that as 8 pi over 8. Okay. Then we're going to find midpoints. So let's find our first midpoint. So 11 pi over 8 plus 3 pi over 8 is going to give us 14 pi over 8. And then we divide it by 2. So it looks like 7 pi over 8 for that one. We're going to add these two together to get 10 pi over 8, and then divide it by 2 to get a midpoint. So it looks like we have 5 pi over 8. And then we can add these two together to get 18 pi over 8 and divide it by 2. So it looks like that will reduce down to 9 pi over 8. Okay, maybe that's not the method you love. So let's talk about method number 2. We take the period and we cut it into fourths, and then we're going to add that 4 times. So let's think of pi over 4 as 2 pi over 8. So we're going to add 2 pi over 8. We're going to add 2 pi over 8. We're going to add 2 pi over 8. And we're going to add 2 pi over 8. Okay, this is a positive cosine curve. So we're going to start in the top corner and make our valley. Okay. So we have 3 pi over 8, 5. We have 5 pi over 8, 2. We have 7 pi over 8, negative 1. 9 pi over 8, 2. And 11 pi over 8, 5. We have a domain of all real numbers, and our range is going to stretch from negative 1 to 5. Remember, our frame helps us with that. Let's take a look at graph number 8. Let's remember that this is a tangent graph, so we are not going to have any amplitude. We will keep in mind that A is a negative 1, and that will help us not only with our frame, but also with the direction of our curve. Okay, let's remember that we calculate the period for a tangent graph by taking pi divided by b. In this case, it looks like b is 1/4. So when we take pi divided by 1/4, we get 4 pi. Okay, we do not have a c value, and it looks like our d value is -2. So our starting point is going to be 0, -2. Okay, now remember, tangent's the weird one. Starting point is in the middle of our frame. Okay, so that's in the center. Okay, so if 0, -2 is in this, our starting point, we're going to use A and go up 1 and down 1, so we at least know where those points will be for our curve. Okay, now we're starting at 0 for our X spacing now, and that's in the middle. So one of two things, we can take this and we can put half the period to the right and half the period to the left, and then find our midpoints. We can also think of cutting that into fourths and adding a fourth to the right twice and a fourth to the left twice. What's nice, since our period is 4 pi, a fourth of that is pi. So we can add pi twice and subtract pi twice. And those came pretty easily to us. Okay. Now, our asymptotes are going to be on the edge of our frame. So our asymptotes are x equals negative 2 pi and x equals positive 2 pi. Please write those as equations of lines. They are not just numbers. Now, since this has a negative a, our tangent graph is going to fall from left to right. And we need to label these points, and our frame helps us figure out where these other 2 points are going to be. Okay. The range of any tangent graph is all real numbers because it goes forever in both directions vertically. I'm not going to ask you for the domain because if we think about this curve that continues on to the right and to the left, we have an infinite number of vertical asymptotes breaking up our domain. So I'm not going to make you write that. Okay, graph number 9. We have a cosecant curve, so we are not going to have an amplitude. However, that vertical spacing will come into play with our a value of 3. Okay, now the period we're going to calculate by 2 pi divided by b. It looks like here that b is 2. So 2 pi divided by 2, we have a period of pi. Okay, now bx minus c is what's inside here. Let's go ahead and just identify that our d value is 1. Now, when we take c divided by b, it looks like b is 2, and our c value, keep in mind this is a negative pi over 2. So when we take negative pi over 2 divided by 2, that's the same thing as multiplying by the reciprocal. So negative pi over 4 comma 1 is our starting point. Okay. So negative pi over 4 comma 1 is our starting point. Okay, so for our vertical spacing, our starting point has a y value of 1, so we're going to go up 3 and down 3, since a is 3. Okay, our frame horizontally begins at negative pi over 4. Method number 1, if I take the period and add it, we would end at 3 pi over 4. If we find the midpoint, we add these to get 2 pi over 4 and divide it by 2. Our midpoint would be at pi over 4. If I add these two and divide it by 2 to get a midpoint, it would be at 0. If we add these two to get 4 pi over 4 and divide it by 2, our midpoint is at pi over 2. Okay. Maybe you like method number 2. Okay. If we take the period and we divide it by 4, we can add pi over 4, add pi over 4, add pi over 4, and add pi over 4. You do what works for you. Now, this is a cosecant curve, so we are looking at the reciprocal of sine. A is positive, so really lightly, I'm going to draw in a positive sine curve. Okay. Now, at these points that hit that middle mark, that is where our asymptotes will be located. So we have asymptotes at x equals negative pi over 4, x equals pi over 4, and x equals 3 pi over 4. Please make sure you write those as lines. If you write them as numbers, you will not get credit. Okay. These coordinates right here is where we will draw our u's. Okay. You can leave that sine curve in there, but it's not necessary. It's not really there. Just make sure that your U's and asymptotes are sticking out more than the sine curve if it's there, like it needs to be really light. Okay, our range is going to be below and including -2, and then above and including 4, because that's where our U's occur. Let's talk about graph number 10. This is a reciprocal curve. There's not going to be amplitude. Okay, I like this one. Look at this. We have a B value of 1, so our period remains 2 pi. We don't have a C value, and then we have a vertical shift of 3. So nice and simple for us for our last graph on this review. So our frame, since A is 1, we're going to go up to 4 and down to 2. Okay. Our frame begins at 0. We're add 2 pi. That's where it will stop. We find the midpoint of pi. We find the midpoint of pi over 2. We find the midpoint of 3 pi over 2. Or if you want to take 2 pi and divide it by 4, we can add pi over 2 each time. Okay, this is the reciprocal of a cosine curve. So I'm going to draw a positive cosine curve very lightly in here. And then I can take these points right here to create our asymptotes. Okay, then we can take these coordinates and they become our U's. Our range for this graph is going to be -infinity to 2 and 4 to infinity, because that's where we have those black U's, and in between there is blank space. Let's look at problem number 11. Now we're asking you to give us the equation for the curve. Okay, so I'm going to draw a frame. You don't have to, but maybe it will help you. It looks like this is a cosine curve. So y equals a cosine of bx minus c plus d is what we're working with here. So let's identify a. First of all, it looks like our frame stretches from -6 to 0. So our amplitude looks like it is 3. And it looks like our curve is a positive cosine, so a is 3. Now, the period stretches from -pi/4 to 3 pi/4. So we need to figure out how long that is. So if I'm going to calculate that, we're going to take where we end and subtract where we start. Okay, so end minus beginning in order for us to get that length. So if we take 3 pi/4 and we subtract a -pi/4, looks like we would get 4 pi/4 for pi. Okay, now we know that we calculate the period by taking 2 pi divided by b. So I'm going to go ahead and set that equal to 2 pi divided by b. So if I were to cross multiply, pi times b equals 2 pi, and we divide by pi, it looks like b is going to be 2. Okay. Now, most important here, our starting point is not where our curve starts, but instead it is where our frame begins. So it looks like our frame begins at negative pi over 4, comma, negative 3. So for sure, negative 3 is our d value. But we need to keep in mind that the x-coordinate of our starting point, which in this case is negative pi over 4, is c over b. Well, we know that b is 2, so let's go ahead and throw that in. So now if we multiply the 2 over to get c by itself, we get c is negative pi over 2. So when we write the equation of this curve, we have y equals a cosine of bx minus c plus d. Okay, this should be a positive because we have shifted to the left. We have bx minus c. Let's look at number 12. That didn't work out very well. Let's try that again. Okay, so I'm going to draw my frame. Okay, it looks like we have a sine curve. So y equals a sine of bx minus c plus d is what we need to be calculating. All right, it looks like our frame stretches from negative 2 to 6. So our amplitude appears to be 4. This is a sine curve that looks like it's down first. So a is going to be a negative 4. Okay. Our b value is determined by the period. So it looks like our period stretches from 0 to 2. So the period is 2. And we know that 2 pi divided by b is how we calculate the period. So if we cross multiply and solve for b, our b value is pi. Now, our starting point appears to be 0, 2. Well, if 0 is that x-coordinate, we're not going to have a c value. So we have y equals a sine of bx. There's no minus c. Whoops, let's actually write b in there, huh? bx. There's no c value, and then we'll have r plus 2. Last but not least, number 13. I'm going to draw a rectangular frame. You know what? This just doesn't want to draw a rectangle for me. I wonder why. Pretty terrible rectangle. Okay, here we go. There's my frame. So it looks like we have a cosine curve. Y equals a cosine of bx minus c plus d. Let's talk about a first. Our frame stretches from negative 2 to positive 2. So it appears that our amplitude is a 2, but this cosine curve is starting in the bottom corner. So a is going to be a negative 2. Okay. The period stretches from negative pi over 6 to pi over 2. So let's take where our frame ends minus where it begins. So if I'm taking pi over 2 minus a negative pi over 6, I'm going to go ahead and think of pi over 2 as 3 pi over 6. This would give me 4 pi over 6. which would simplify down to 2 pi over 3. Now, this is our period, which we calculate by taking 2 pi divided by b. Well, if 2 pi over b equals 2 pi over 3, then b is 3. Okay. Now, our starting point is at negative pi over 6 comma 0. Well, we know that d is 0. That gives us that right away. But our x coordinate, we calculate by taking c over b. So c over b is our negative pi over 6. Well, if b is 3, we can go ahead and substitute that in. If I just multiply that 3 over to the other side, we can get our c value to be negative pi over 2. So our curve, y equals negative 2 cosine of bx minus c, and then we don't have a d.